G4E, HF mobile radio installations, emergency and battery-powered operation. What's a capacitance hat when referring to a mobile antenna? A capacitance hat is a device to electrically lengthen a physically short antenna. And that becomes very important in mobile installations for high frequency, because a normal full-length antenna is too long to put on a car or a truck. You'd be hitting all the overpasses. So you shorten the antenna by adding an inductance in the antenna, but you can also help do that and help with the tuning of it by putting a capacitance hat on the antenna as well. Those aren't for decoration or for catching birds. They are for electrically lengthening a physically short antenna. Here's another example of a capacitance hat. This is on a fixed location just a few miles from me here. And this is a Federal Aviation Agency non-directional beacon. And you can't see it very well in this picture, but there's an antenna tuning unit in a little building right here. And then there's a vertical wire that goes up here to this horizontal wire. Okay? Here you can see that in detail. This vertical wire comes up here, and it splits, and it goes to the two horizontal wires. Okay? The actual antenna here is the vertical wire, and it's physically short for the frequency. The horizontal wires on here provide a capacitance hat to help tune that system. What's the purpose of a corona ball on a high-frequency mobile antenna? Corona is a high-voltage discharge, and it's the corona ball on the antenna is to reduce high-voltage discharge from the tip of the antenna. That's the electrical reason for it, and that's the test answer for it. It also makes the antenna much safer around people, so if you get the end of the antenna in somebody's eye, you're not going to do as much damage as if it was not. Didn't have the ball on the end. But the test answer for this is to reduce high-voltage discharge from the tip of the antenna. Which of the following direct fused power connections would be best for a 100-watt HF mobile installation? The correct answer is to go directly to the battery using heavy gauge wire. And here is an example. This is an illustration from an installation manual for an actual radio. I believe this was an ICOM. And here they show you making the connection directly to the battery posts on the car, which is the best way to do it. That's not always easy to do, but often you're able to do that. So the red wire, the positive wire, goes to the positive battery post. The black wire or the negative wire goes to the negative battery post, or to a ground location somewhere near there, as close to the battery as you can get it. And that helps eliminate as much noise as possible. Now it's very important, since you've gone directly to the battery, that you have fuses fairly close to this. You want fuses before you pass through any firewalls or any place where the insulation on your wire could be chafed. Because if that should happen and the fuses are not between the damage point on the wire and the battery, you're going to have a fire. So it's important that the fuses in this kind of an arrangement be close to the battery. It's also important that you remember to turn your radio off, because turning off the key isn't going to do it. Your radio will remain on, and if it's on for an extended period of time, it could drain your battery. But this is the correct connection for a high-power, mobile installation, either HF or VHF for that matter, directly to the battery using heavy gauge wire. Why is it best not to draw DC power for a 100-watt HF transceiver from an automobile's auxiliary power socket? The socket's wiring is not going to be adequate for as much current as you're going to need. A 100-watt transmitter is going to need about 20 amps, and those sockets just are not designed to do that. I've done it with lower power transceivers, but for a 100-watt transceiver, you would not want to do it. Another good reason not to do it is because it gives the electrical system more opportunity to introduce noise into the power, so that you could have additional electrical noise in your receiver from that kind of a hookup. Which of the following most limits the effectiveness of an HF mobile transceiver operating in the 75-meter band? The biggest problem is the antenna system. A 75-meter antenna, even a quarter-wave antenna, is going to be what, 37, right around 17 meters long, and that's about 50 feet. So you're going to have a hard time putting a 50-foot vertical antenna on a car or a truck. So the antenna system is the limiting factor for HF mobile installations. What's one disadvantage of using a shortened mobile antenna as opposed to a full-size antenna? A disadvantage of using a shortened antenna. When they shorten the antennas, they have to put inductors into them like this. And in doing that, the operating bandwidth may become very limited. So where if you had a full quarter-wave antenna, you might have a fairly wide bandwidth. With the antennas that are tuned using the loading coils and so on, the bandwidth will be narrower. It'll give you a narrower range of frequencies that you can operate without having to adjust the antenna. Which of the following is most likely to cause interfering signals to be heard in the receiver of an HF mobile installation in a recent model vehicle? The vehicle control computer is the correct answer for this question. I've heard of anti-lock brake systems causing interference also, but the most continuous source of it's going to be the vehicle control computer, because that's running all the time. What's the name of the process by which sunlight is changed directly into electricity? That's called photovoltaic conversion. Okay, sunlight changed directly into electricity. Photo, light, voltaic, electricity, conversion, changed. So the answer is right there in the question. And here's a simple system. Light from the sun, solar panels, charge controller into the battery, and then battery however you're going to use it, either as DC power or through an inverter as AC power. What's the approximate open circuit voltage from a modern, well-illuminated photovoltaic cell? It's about half a volt from each of the little cells in the panel, and then those are connected in series and parallel to give you the whatever voltage the panel has been designed to provide, voltage and current. But each individual cell is going to be about half a volt DC. What's the reason a series diode is connected between a solar panel and a storage battery that's being charged by the panel? That series diode is not important in the daytime when the sun is shining. However, when the sun goes down, the battery will try to put current back through the panel. And we know that a diode allows electricity to pass in only one direction, so it prevents the battery from self-discharging through the panel in times of low or no illumination. Which of the following is a disadvantage of using wind as a primary source of power for an emergency station? A large energy storage system is needed to supply power when the wind is not blowing. Same disadvantage as solar. Your solar, if you're using solar for your emergency power system, it is not producing electricity when the sun's not shining on. So in either case, either the wind or the solar, you need a large energy storage system, which is talking about batteries.